Hello, and welcome to this presentation on Maths in the Early Years at Ravenstone. I'm Simon Lewis, I'm the Early Years Coordinator, and I have a passion for teaching maths for our youngest children in school. I love maths, we love maths. This is something we say before lots of maths lessons and maths meetings. This is a mindset about maths being fun, maths being relevant, maths being accessible to all. It's very important. It's a mindset we changed across the school maybe 4 or 5 years ago, about maths being for everybody and not something we should worry about and children to be anxious about and teachers to be anxious about, because we love maths at Ravenstone. So in this presentation, I'm going to be looking at what the curriculum says, what we say, differs from the curriculum a little bit, what happens in nursery, what happens in reception and how is it different, what is maths mastery, some of you might have heard maths mastery, how it relates to the early years, and how you can help at home. So to begin with, the curriculum. The curriculum is broken down into age bands in early years, rather than year groups. It's not just nursery and then reception are different things, but age groups, different how old you are. The model is a best fit model, so there's lots of different things each age group should do, and the child needs to have most of them to progress to the next level. And it's made up of 2 areas, number and shape, space and measure. So these are all the things that a child needs to do in number from 30 to 50 months. I won't go through every single one, but you can see it's very much focused on number. Maximum to 10, so 30 and 50 is nursery going into reception. So focus on numbers to 10, no more than 10. 10 is enough, and I'll come on more than that later on. Using numbers in their play, counting on, showing interest in number. So if they're playing with cars and they can count the 4 wheels, that's the kind of thing we're looking for. Numbers that are relevant to them. Comparing 2 groups, which is larger, which is smaller. A curiosity number, so language. It comments about comments and questions, which is really language. It's very important. The language of maths, being able to talk about maths, being able to communicate maths. Obviously, you can go back, these are online, and you can also go back to these and have a look at them later on. 40 to 60, so this is reception. This is what the reception children do. Obviously, if a child in nursery is doing really well, they will move on to this area, but these are the 40 to 60 month brackets. Again, you can see to 10 and then 1 or 2 comments to 20. That's all. We're looking to 20, not because we don't want to push the children on, but because there's so many things to do to be secure to 20. Doesn't mean just counting to 20. So many more things to do to get a really grounded knowledge of number to 20. They can get that solid base when they get into year 1, they'll be flying. So that counting on, counting back, 1 more, 1 less, grouping together, estimation. There's lots of really good things in there. I'm going to like this. The curriculum's good. We like the curriculum. There's lots of really interesting things in there. Some things that we teach that are missing, but we'll come on to those. And this is the early learning goal. This is the phrase that the child has to be able to do by the end of early years. So end of reception, leaving reception, going to 1. This is the phrase that the government have to whether the child is passed or not the early learning goals in maths, in number. Now, it's a very small statement, really. There's so much more underpinning this that we think whether a child is at age-related expectation doing really well, or the child maybe needs a bit of support. But in basic, it's doing all the things 20, up and down, and then problem solving and using that number knowledge in a different way. Okay? So it's left open to interpretation. We add things to it to make it richer and more relevant for the children. Now, in what we consider, and this is helped by the NECTM group, this is what we consider the primary things in early years that make a good mathematician. So the first one, cardinality and counting. This is the number. This is the oneness of 1, we call it. What does 1 mean? What does 2 mean? How many is it? Can you count that many things? Like if I ask for 3 things, can you give me 3 things? If I ask to count how many there are, can you count how many there are? Okay, that's the first thing, counting. Really important. You count every single day in nursery and reception, and it's a skill that you practice. If a child you think can count to 20, you still practice it and practice it and practice it. Next is comparison, looking at 2 groups, which is more, which is less. You can't do addition and subtraction and multiplication and more complicated maths unless you can work out which is a larger group, which is a smaller group. So comparison of items, estimation comes in there as well. So looking at a block of numbers and saying how many are there? Is it 3? Is it 100? Having a rough idea of how many things are. A composition. This is the start of addition and subtraction. This is knowing that a number can be made of 2 numbers or more. So we do this, we know that that's 10, and it's made up of 5 and 5. Okay, fingers, very important. Okay, looking at 4, and then it's 2 and 2. It's also 3 and 1. So we use a lot of hand movement. So we ask for 4, show me 4, show me 4. Show me 4 and 2 hands. Ah, that's 4 as well. Can you do it in a different way? Ah, I can, 3 and 1. So if they can break numbers down into smaller quantities, then it's a really, really useful skill. I mean, it's very important. This is the baseline of everything you can do. You might be able to count to 20 or might count to 10, but if you can't break that 10 down into different parts and know that 9 and 1 is the same as 8 and 2, which is the same as 5 and 5, then we haven't got the understanding and the deep level of knowledge. The next is pattern. If you know me, I'm an advocate for pattern. I've done lots of research on pattern. Pattern is essential. Pattern develops mathematical brains, an understanding of how things are formed. So simple pattern of red, blue, red, blue, red, blue. If they can continue that, if they can make that, if they can debug that, already in reception, so your parents will realize that people are doing pattern a lot already. Okay, other pictures already of wonderful patterns coming out of reception, really wonderful. And that started in nursery. And for those joining the school, we'll get you up to speed, up to speed really quickly, because lots of places don't do pattern. And it mentions it briefly in the early learning goals, but only briefly. And we've lots of research shows that the more you do pattern, the more understanding you have of maths, because maths you're trying to find patterns in number. Okay? Doing times table is a pattern. 2, 4, 6, 8, 10, 12 is a pattern. So if you start on with color patterns and shape patterns and animal patterns, then it really develops a mathematical knowledge of looking at things and finding commonalities. Shapes and space. That's what do shapes look like? How do they join together? How do things, the qualities of shapes like sides and corners, that kind of thing. And that also is in the physical world of building, construction, Lego, blocks, it's all shape. It's really important. Again, like pattern, if a child that can build in a formation, in a symmetry, that kind of thing, has a mathematical mind. And we have, in early years, have a job to develop that mathematical mind. So they see the world in this way. And then finally measuring length, weight, volume, capacity. Starts off in water play, filling jugs up. How many jugs does it take to fill this cup up? Can you fill the sand? Is it full? Is it empty? It starts with that. Starts in play. All this starts in play. Okay. So in nursery, what do we do in nursery to teach maths? So we have the formal side. Obviously nursery, not much formal teaching in nursery, little bits of carpet sessions. And then we have learning through play. So the majority of the day in nursery is play. And then language. So what we say as adults to model mathematical language to the children. So carpet session, at the moment, our carpet session in the morning has some maths in it. We do, it's very mixed. We have number of the day. So we choose a number every day, different ways. We may count that number, we should have a number on our fingers. We might break that number down into smaller parts. We might say which is bigger. Each day we do have a number and we do something with that number. Days of the week. So we look at the days of the week, learning days of the week, but with that becomes number 7. So every day we hold up 7 fingers on 5 and 2. So we know that week and weekend. So we count and then I'll wiggle the number. So this one is, that way. Yeah, Friday. So from Monday, Tuesday, Wednesday, Thursday, Friday. So if I wiggle a finger, they will say, oh, what day is that? That's today. Yesterday, tomorrow. So already we're looking at ordering things, the cardinality, so first, second, third, fourth, fifth day of the week. Realizing that 5 and 2, so you're breaking them down, you're doing breaking them down into smaller parts. 5 and 2 is 7. So all that thing, all those items are really drilling down into number. Counting, finger work, as I said, constantly using our fingers. We'll do quick finger games, 25, and then you do bunny ears. So you ask them to show you 4 with their fingers like this. So they can't see, so they're not doing this to count. They happen to feel how many 4 is. And then that develops when they're ready. Usually happens after Christmas, but it depends on the cohort. If they're really ready for changing, then we do earlier. We split the morning session into maths only, and then the session before lunch into a more kind of literacy, phonics, story based. So we split it up a little bit, just do a bit more maths. And there we add pattern, we add odd one out. So pattern, as we start after Christmas, and then odd one out is a way of having 4 pictures on the board, and they can be anything from shapes to animals to fish to vehicles, and it's the idea of working out, doing problem solving. So I think, using full sentences, I think the car's the one out because it's the only one with 4 wheels. So using a full sentence, an exclamation, there's never a right or wrong answer. But as long as they can explain and give a reasoning for that, then that's the right answer. Okay, so that's the formal maths in nursery. And then we have lots and lots and lots of maths throughout the day. So building, mathematical, shape space, how tall is it? How many blocks do you need? Races, timing races, tidying up. Really good way of doing maths is tidying up. Oh, we need 4 pens in that pod. Can you park 4 bikes in that bike park? Using maths to question them, and they don't know that they're learning maths, they're just doing it every single day. Games, so we play board games in the afternoons and mornings sometimes. We have a huge amount of board games using dice, very important. And all the time it's our job as professionals to bring the maths to the children. If they're building a den, we will then talk in mathematical language for them to build a den. So we're doing it today, we're building a den. One side didn't have many sticks, so I said, oh, there's no sticks, there's only a few sticks on this side, how many are there? And then someone counted them, and we all counted them together. And I said, oh, we need 4 more sticks or 3 more sticks. And they went to get 3 more sticks. We checked that was the right number. Then we said, oh, how many have we got all together? And we had to count the sticks again. So it's our job to bring that maths, and it's useful and it's pertinent to the child. Inside, again, construction, cooking. B makes Play-Doh with the children every week. 4 children every week get to make Play-Doh. They're measuring that out. How many spoonfuls of flour do we need? How many cups of oil? Constantly using maths language to cook. Small World, when they're playing with toys, playing with train sets. How many carriages of your train got? Snack. Oh, how many people at the table do we have? How many apples do we need? Do we have enough apples? Do we need 1 more apple? 2 more? Too few apples? And then again, tidying up. So you can see the amount of maths we have every single day is huge. And then being to language, as I said, language is so important. We speak in full sentences all the time to the children. And if they don't speak in full sentences, we model that correct language to them. So if you say, how many trains have you got? And they say 4, we'll model, I've got 4 trains. And it's just that additional language. And then also, if they're saying, it's to the top, we say, yes, your salmon pit is full. So we will remodel that language with mathematical terms in it and using full sentences. Language, and we're not afraid to use mathematical terminology. So we'll use the word capacity. We'll use maths language like add and subtract. It's very important to be accurate with that math language now, because the children absorb it. Children will just, it's no more difficult the words that we use every single day. So it's really important to get the terminology right. And then it's our job to bring the maths to the play. So how is it different in reception? So they have a bit more formal teaching, a bit more formal carpet time, maths meetings and math lessons. I'll tell the difference between those two. Then we have child initiated and child adult initiated, and again, language driven. So Math lessons. So a math lesson is where you introduce new ideas. So it might be that you're going to do capacity. And so that's the first year you do a math lesson. You'll introduce it formally. You might have a slide presentation in the classroom, even for reception, and you'll go through what capacity is, or you might model pouring things from one jug into another, and what that looks like. New ideas, new concepts, new topics, and you're starting something new. Okay. It's also if maybe you've had something like you realise the class as a whole haven't got an idea, so you might redo an idea. So something's not working. So say reception struggling to get pattern, you might redo pattern again in a math lesson. They haven't, they've been awesome at it, but or you might look at say doing something else in patterns, so debugging the patterns or introducing algebra to the patterns. Yeah, algebra and reception. That's what a lesson is for, and it usually lasts about 30 minutes. Okay, it's not one every single day, but there's throughout the week you introduce new topics or to debug, sort of demystify misconceptions for the class. A maths meeting, what we call, is a very sort of repetitive, repetitive not in a negative sense, but what happens is you'll have certain topics, so you have a pattern, you'll have a number, a bit like we do in the mornings with our carpet sessions. You have the same things every day for a week, and then you tweak each one. And the idea is quick fire, and you go through lots of topics, and it's to keep that mathematical brain constantly ticking. And we found it's the most useful thing we've ever done. It's really good. It's always small steps. So every day you change it a little bit. You might add a little bit. The change might be so minuscule, but you're constantly building every single day on the day before. And they become really fluent in the math language we use. And it can last anything from 5 to 15 minutes. I say even less than 5 minutes sometimes. If you've got a line, we're queuing up to go to dance and you've got a spare minute, then you might all count upwards and backwards. That's a math meeting. It's a way of reinforcing already learned things, but making sure that it's absolutely fluent in the child's mind. And then, of course, learning through play and I should say reception. And adults, so there's two different kinds. Obviously, there's more kind of directed work in reception. So after a math lesson or pattern or a math meeting, the teacher might set that everyone has to do a pattern throughout the day. And they have to come to a table, do that pattern. That's your adult initiated. That seeks to look at what they can do. So assessing, can they do the thing? Do they understand it? How can I stretch them, make it more interesting, or to extend that child? Other misconceptions. If a child you saw in the math lesson wasn't quite getting it, then you'll do some directed work with that child to make sure they're moving at the same pace as everybody else, and help individuals to progress. Interventions. And then child initiated is exactly the same as nursery. Whatever they're doing, you might bring some math to them. So construction, small world, tidying, adult supported. So you are bringing the maths to them, just like nursery. So there's a lot of information here. Please feel free to go back and watch it as many times as you want. It's awesome. So now it's the cornerstone of reception maths. So these are the things that we use in reception all the time, and nursery, to be honest. So finger counting, subitising, I'll explain what that is, patterns, part whole, and eventually the bar model. Okay, these are the things we use to teach number and mathematical learning. So finger counting. Now it might seem, counting in your fingers, rather sort of young, kind of very 2-year-old kind of way of counting. It is not. It is really important. All the research shows that using your fingers to count links what you see to what the sort of the abstract in your head. So it's concrete, the things, to abstract, thinking about number, understanding, doing maths in your head, doing mental maths. So you see that is 10, you feel it's 10, so then you know that number of things is 10. Okay? It's the first ever counting tool used. All cultures use finger counting. It's physical, so you can touch it. And you'll see in nursery, at the moment, you ask lots of children to do 5 or 4, they're going 1, 2, 3, 4. You ask them to do 4 again, they'll do it again, because they haven't linked that feeling of 4 things rather than going 4 every time, 4. In reception, lots of children will just go 4. They know 4, or they know 4. or they'll do 10. They'll know straight away what the number is. But early start, when you start using your fingers, they're still feeling one at a time. And that's why you do the bunny ears. So you can't do that. You have to know what it is. It teaches one-to-one correlation. So counting one thing each time. One of the primary rules of counting, you count each thing once. It's immediate assessment. So if I ask the whole class a number and they do it, I can see straight away who understands it and who doesn't. And then the ones that don't, I can then help afterwards. Okay. There's a video. I'll forget a little bit more about that. Next is subitising. Now, subitising is very important. It's the counting of items. Well, not the counting of items, knowing how many items there are without counting. Okay, seeing a group of items and knowing how many there are straight away. So the obvious thing of this is on a dice. So if you look at a dice, you know how many it is. You don't count the dice dots each time. So if you look at the raspberries, you can see there's 5 raspberries, 3 blueberries, 5 raspberries, 13. Okay, so you know that. I've worked that out because I know that that shape is a 5. The 3 down is 3 and the 5 is 5. The ducks, well, it's 12 and 1 missing, or it's 6, 2 and 3. People will see it in different ways, but you should be able to get the number without going 1, 2, 3, 4, 5, 6. Now, so dice is the very first input of this. So I hope you are all playing board games all the time. Every time your child is bored, get a board game out, play Snakes and Ladders. You will not understand how much Snakes and Ladders can improve your child's maths. It's a phenomenal thing. So it's just a simple tool, playing, counting, rolling dice. It's great for turn taking as well. Good for understanding how to be a good loser. Phenomenal. Number 1 tip, play Snakes and Ladders. So subitising, it promotes early number sense, helps develop the ability to perceive subgroups. So with the ducks, I've seen that 11 is made up of 6, 2 and 3. I've seen that 13 is made up of 5, 5 and 3. I've seen those groups by knowing that 5, 5 and 3 make 13. It's good for language, to verbalise. So we get the children to either say, how many is that? They say 7, and they say, how do you know? And they tell you why. It's an excellent assessment tool again, and it's very creative. The children can draw their own, which is really good insight of how they think about numbers. If you ask them to draw 5, they do 5 individual dots, then they're not seeing number in any kind of form, any kind of group. If they draw it as a dice pattern, you understand they know what 5 is. And the bottom there, you can see that's 5 in different ways, different people drawing 5. The first one, obviously, dice pattern. The second one, 3 and 2, which is very nice. The third one, not really any form. D, not so much. E, excellent, a 4 and a 1. Okay, so all those give a different insight into what the child understands about number. Try it with your child, try it with your own child. Get them to draw dot patterns of different numbers, see what dot patterns they do. Okay, so this is how we teach subitising. So we will show it on the screen, then we remove it, and then we say how many. Well, 1. Next one. Oh, behind the thing. How many? Yeah, 4. It's a square. We teach 4 is a square. Number blocks. 4 is a square. How many is that? Yeah, 8. 4 and 4. Did you see 4 and 4? Did you see 8? Did you see 2, 2, 2, 2? How did you see it? Last one. How many? What did you see? So 4, 4 and 2. Or did you see something different? 1, 8, 1. How did you see that? So really good subitising. Pattern. Talked about pattern a lot. We do patterns there. Lovely children doing patterns. So we start with a simple 2-colour pattern, repeating pattern. All patterns we do, well, not all, but lots of patterns we do are repeating. And this is called an A-B pattern. Now, eventually, not yet, but we will assign values, algebra. So red is A, yellow is blue. So it's AB, 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 AB. So then you can generalize and say it's an AB pattern. And then you don't have to do anymore because you know it repeats forever. And that is algebra, and children at the end of reception will be able to do this. It's mind-blowing. This one, it's a BCAA pattern. And lots of children will do this at the end of reception. And a circular pattern. So can you do a pattern that starts and ends and go round and round and round in an AB pattern or an ABC pattern? Okay? So start with the 2 colour patterns, make them at home. You're cooking, you're doing pasta, penne, spaghetti, penne, spaghetti, penne, spaghetti. When you're doing little fruit, lay it out. Apple, pear, orange, apple, pear, orange. What comes next? Get them to make their own. Make a one with a problem in it. Get them to solve that problem. Okay, one more thing. Part, whole. Again, we talked about having a number made up of 2 other numbers, the start of addition. This is called part, whole. We use this towards after Christmas or towards Easter. We start looking at how to break one number down into 2 bits. So the 2 parts. So for this one, 5 and 2 makes up the whole, which is 3. We say part, whole. Okay. So key stilling using key stage 1. It's a precursor addition and subtraction. If you can do this, the next step is to write it in an abstract form of 1 + 2 = 3. It's visual. It's the middle part. So we talk about concrete first, things. So 2 things plus 2 things is 4 things. That's the concrete. And the visual, and you draw it as a picture, which is kind of this there, that's picture. And then the abstract, which is a number sentence. And increasing understanding of the other work we do later on. It's really important to get right. Because if you look here, 7 and 4, okay, we want to add those 2 together. If you ask a child what 7 and 4 is, what we want is then to break down the 4 part, the whole, into 2 parts, 3 and 1. That's the first step we want them to do in their head. This is the mental math, is what mathematicians will do, some of them. Then you see that 7 and 3 are number bond. 7 and 3 make 10. Got 1 left over, it's 11. So that's what we need them to do in our head. Not go 7, 8, 9, 10, 11. Because that is a dry skill that only gets you so far. Okay, counting on, while useful in some respect, doesn't give a solid understanding. Okay, nearly finished. Well done if you made it this far. So, maths mastery. Lots of people have heard about maths mastery. It came from the Singapore maths. It's widely used. Lots of schemes you can buy into, courses you can go on to, work you can get, books you can buy. The picking out maths mastery and making kids geniuses. Ultimately, it's just good teaching. Okay, if you did good, solid teaching, that's maths mastery. Controversial for some, but it has some key points. Okay, teaching maths for mastery involves employing approaches that help pupils develop a deep and secure knowledge and understanding of maths at each stage of their learning. So at the end of every school year or stage, pupils will acquire mastery of that mathematical facts and concepts they've been exposed to, equipping them to move on confidently and securely to more advanced materials. So ultimately, understanding the bits from that year really well. Okay? Not rushing ahead, but really having solid knowledge, mastery of those topics. Okay? Which is why I go back to the fact that 10 and 20, we don't need to go any higher than 10 and 20 in early years, because there's so much to do with 10 and 20 to get right first before we go higher and higher numbers. If a child can count to 50, that's great. Practice counting to 50. Kids love counting big numbers. That is not a problem. However, to say they are secure to 50 or 20 is not necessarily true unless they can do loads of different parts to 20. Okay? Mastery is something that all children can achieve, which is absolutely fundamental, and we believe that is true, that all children can be masters of maths. Okay, maths mastery. Whole class moves forward at broadly the same pace. That's the idea. Okay, we want to bring the whole class through at the same pace. Obviously, if a child is high flying and really, really loves maths and is really going for it, we will always give them work to do, always extend them, always make sure that they are achieving everything they can achieve. And for the ones who are struggling with maths, who find it a bit more tricky, we'll always give them interventions. But the idea is to move the class through the subjects at broadly the same pace. Each topic is studied in depth. So for nursery, for 5, we will go for so many different things to 5. Can they count 5 up and down? Can they do 1 more, 1 less to 5? Can they break 5 into different parts? Can they count, give me 5? Can they estimate to 5? If you put 5 things under a sheet and say how many are there, do they still know it's 5? If you take one out underneath that, can they work out there's only 4 left? So many different things to do to make them say, yes, I have 5, then go to 6 and 7, 8, 9, 10. There's no point going higher if they don't really understand to 5, because these are the concepts. The numbers just get bigger and bigger and bigger. Teachers not move on to the next stage until they can demonstrate that the child has really understood it. So I'm not going to count with a child to 10 necessarily until I really know they understand to 5. Okay. The climbing frame at the top of the picture, that is an analogy that's constantly used, that education in general, particularly maths, is a climbing frame, not a ladder. You don't know this, and then you know this, and then you know this, then you know this. Because sometimes you forget this, and then you've got a rung missing in your ladder, and then you're a bit stuck. So climbing frame, you go up a little bit, you go across, you go down, you try that again, do some more work down here, you go up again, then you go across. So you build a very broad, solid structure, not a wiggly ladder that can fall down. So they have to be able to do, to get the right answer. So you give them something to do, say, well, can you tell me what 2 and 2 is? And they say 4. Okay, well, that's great. How did you do that? How do you know it's 4? That's the bit. They can explain how they got the answer. That is the key. Okay, that is why they said, well, I had 2 and I had 2 and I counted them together. Or, well, I know that 4 is a square and I can draw a square. Or they can explain how they know that 2 and 2 is 4, what their process is. Show your workings, basically, but verbally be able to explain that. That is understanding of mastery. Otherwise, you go through school, you can get the right answers, then something changes, or you try and use that information on something else, and you struggle because you don't understand why you're doing it. The why is so important. Finally, what you get to do at home. Lovely making Play-Doh there. So, snakes and ladders, look at that. Shopping, okay? Billy, go and get me 10 apples, please. Susan, can I have 3 carrots? Go and get them for me. There you go. There's your counting. Can they count 3 apples? Count them into the bag. Say, oh, wow, I think we need 1 more apple. Can you get me 1 more apple? So maths all the time in that. Spot how many spots. Count the cans on the shelf. How many things have you got? How many pieces of bread have you got in the basket? All this kind of stuff. Shopping is a brilliant way of just chatting about maths as you're walking along. Just ask them questions about number. Count for them. Okay. When you're doing your workings out and you need to think, oh, how many days of the week have we got to buy dinners for? Say it out loud. Ask, just talk about it. You don't have to ask the child questions. You can just say, well, we need to have 1, 2, 3, 4, 5 meals. Okay, we're going to have chicken on 1, 2 days. That means how many days left have we got? Oh, 1, 2, 3. Just narrate that. Board games. Massive fan. Do board games. It's a no-brainer. Okay, do board games. Counting songs and games. I'm sure lots of you do that already. We sing songs with counting in all the time. It's from 5 little ducks to 10 monkeys jumping on the bed. And when you do, use your fingers. Okay, get them to, when you're counting down the 10 green bottles, count down the 10 green bottles, or have 10 green things on the table and take them away. Use physical things. Building, construction, measuring. Okay. Work out how many footsteps it takes to get from here to here, or how long it will take to get from here to here. Cooking, as I said, from the Play-Doh, it's a phenomenal way. You've got counting, you've got time, you've got measuring, you've got weighing. There's so much. And the last one is pretty important. It's very tempting to think, I'm going to get an iPad maths game. They're great. I mean, they're fine, but maths is always better with things, with actual physical things to move and touch and point to. That's how children learn maths the quickest. You want to teach your children to do maths? That's what you have to do, is count objects, move objects, measure objects, feel them, the concreteness of items. That's how you count. I love maths. We love maths. Thank you very much. You know where I am. If you've got any questions, as you can probably tell, I can talk about maths all day. Please feel free to drop me a line, have a conversation, ask some questions, whatever you need to do. That would be great. Thank you very much for watching. Take care and bye.